Alright, this is the Geometry Chapter 1 final review for Semester 1. We've got a lot of different objectives from this Chapter 1. We're going to kind of go through these and talk about them, and then we're going to do some example problems. So we start off Chapter 1 by making nets and drawings of three-dimensional figures. That was right here, this first objective. After that, we then talked about the basic terms and postulates of geometry, which from we were able to build theorems throughout the semester and corollaries and such. Then we talked about finding and comparing lengths of segments. We then talked about their finding and comparing measures of angles. After we were able to kind of compare those angle measures, we were able to identify special angle pairs and use their relationships to find other angle measures, or x, different variables. We found the midpoint of a segment and used that then to find other things. We found the distance between 2 points in the coordinate plane. That's your distance formula. That will come back all the time. And then we found the perimeter or circumference of basic shapes and the area of basic shapes. So what we're going to do is we're going to go kind of through some of these specific objectives and do some problems like them. So the first one we're going to kind of talk about is this that students will be able to understand basic terms and postulates of geometry. It says name the ray opposite ray CD. So first off, a ray. A ray has a starting point and an ending point, and it goes in a direction. So this ray starts at C, goes towards D. Now it goes on forever past D. That's what a ray does. So it goes on forever at one side and ends on the other side. So this idea of an opposite ray is a ray that goes in the other direction, but has the exact same starting point. So it's going to be at C as well, but it's going to go away from D in the other direction, which means actually there's two different names you could give this ray, this opposite ray. You could call it C, always have to start with that endpoint, B, because it's going towards B, or you could call it C, A, because it's also going towards A. Either one of those will work just fine. So once we talked about rays, we then kind of started talking about points, lines, and planes. So it says name the plane points F, G, and H lie on. So in this picture, we've got actually 3 points, F, G, and H. We've actually got 2 planes, L and M, and we actually have a line here as well, and technically a line here as well. So I like to just identify these 3 points. Where are they? So here's F, here's G, and here's H. So these solid and dashed lines are actually really helpful here. The dashed line tells you where the 2 planes intersect. That's where they meet. And then the solid line is actually a line that goes through a specific plane. So if you kind of follow those endpoints of that solid line, you can see that both of those are on plane L. Why that might be useful is because if you look at these points, F and H are both on that plane. Oh, G is too, because G is the intersection of the 2 planes. So if all 3 of these points are on L, plane L is the plane we're looking for. And there you have it. Notice that we name planes with cursive letters, but we name points with lowercase print letters. So after that, we talked about being able to find and compare lengths of segments. It says find the length of GH when FH is 21. So I'm looking for GH, that's here, and I know FH is 21. We had something called the segment addition postulate, which says the sum of the parts is the whole thing. That means these 2 parts, FG and GH, have to add up to get you that whole thing 21. Well, we can do that to help us start off by getting X, and then we can go find GH. So I took FG plus GH is the whole thing 21, and I would just start to do some algebra. Combine my like terms, move things over to get the X by itself, divide, and we get our X. Now I can guarantee that if this is a multiple choice test, you would have 2 as an answer. But 2 is actually not GH, that's the variable. So you have to then take that 2 and go plug it in for GH. We go 9 times 2 plus 2, and we'll get our entire segment length. We get 18, 9 times 2 is 18, plus 2 is 20. GH equals 20. And if you think about that for a moment, the whole thing is 21, which should tell you that this is kind of a bad picture. And you'll come across that a lot on your final, that the pictures are not drawn to scale. So just because something looks bigger doesn't mean it is. All right, so this is a similar question, but this time they say find the length of QS, so Q to S, that's the whole thing, when R is the midpoint. Being a midpoint is a big deal. A midpoint means something's in the middle, and not only that it's in the middle, that it actually results in two congruent parts. So QR and RS are the same, which actually allows you to set up an equation. If you have two equal parts, well, I can say that their lengths are the same, and I can start to solve from there. So why don't you pause the video here and try to finish solving this one on your own. You're going to see some of my work here. I set up that equation with you guys. I solved it. I got x equal to 5. And then I followed those red arrows. I took that and plugged it back in over here in red. And I got 7 times 5 plus 9 was 44. And 3 times 5 plus 29 was 44. Now I should have gotten those to both be the same thing. If for some reason you don't, since they are equal parts, you made an algebra mistake at some point and you need to check your work. So then I went, well, QR is 44. That's what I put right here. RS is 44, so I put right here. Well, then I go, oh, these two together make the whole thing. Add them up. 88. QS was 88. Okay, so we're through two objectives now. We're going to move on to the next one. Next thing we kind of really started talking about were angles. It says students will be able to find and compare measures of angles, and students will be able to identify special angle pairs and user relationships to find angle measures. It says, what is the measure of angle ABC? So first off, the important thing is actually identify where that angle is. It goes from A to B to C. So that is this right here. If you look at that right now, with ABE, you can see that these two make a straight line, which should make you think one of two things. I would think supplementary or linear pair. When a pair of angles are supplementary or make a linear pair, that means they add up to 180. So if I call this angle X, I'm going to say, well, 40 plus X is 180. I subtract 40. And I get x equals 140. Now when you present your answer for an angle measure, you say M for measure, angle symbol, ABC, the name of the angle, is 140 degrees. And that's how you would properly present your answer for that question. So what I want you to do with these next three things is try to write the definition for supplementary angles, complementary angles, and vertical angles. Do your best to kind of remember what does it mean for these things to happen. If you need to use some examples, pull some examples from the picture up above. But why don't you pause the video and try to write your best definitions for these. All right, you can kind of check my formal definitions. Supplementary is a pair of angles whose sum is 180 degrees. Complementary angles are a pair of angles whose sum is 90 degrees. Vertical angles, you might not have gotten the full definition. It's a pair of angles whose sides make straight lines. You may have noted that they are congruent to one another, like the two pairs of 40 degrees, or the pair of 40 degrees up in the picture, right here, are 40 and are 40, and then the pair of 140 degrees, those are opposite vertical angles. The other phrase we use is we call them opposite of each other. All right, so then next thing is just to classify the angles below by their angle measure. Remember, when you classify angles by their angle measure, you're classifying acute, obtuse, right, or straight. So pause the video here and try those ones. You should have gotten acute, acute, and then obtuse. Remember, to be an obtuse, it's greater than 90 but less than 180, the angle measure is. To be acute, less than 90 but greater than 0. To be a right angle, it's exactly 90 degrees, and if you're a straight angle, it's exactly 180 degrees. We've got 2 more pages left to go. These ones where we do a little bit more computation. It says students will be able to find the midpoint of a segment and find the distance between 2 points in the coordinate plane. So it says the midpoint of segment CD is M, and it's -2, 1, and one endpoint, or C, is at -5, 7. What are the coordinates of the other endpoint D? So when we did this one in class, the way we talked about it is we talked about stacking. So we would stack an endpoint over the mid over an end, because that's kind of how they work. So I have an endpoint C, that's going to be at -5, 7. So I start with that, -5, 7. That's my C. My midpoint M, that's going to go in the middle, -2, 1. And then my D is what I'm looking for. That's going to go last. And so the way we kind of think about this is we look at the change that's happening, because the change between the endpoint and the midpoint here will be the exact same change between the midpoint and the endpoint. So from -5 to -2, I'm adding 3, so I'm going to add 3 here. I go negative 2 plus 3. I get a positive 1. I'm going to do the same type of concept here. I go 7 to 1. Well, that's getting less. That's subtracting 6. So I'm going to do the same thing here. And this is where it's really important to know your subtraction to your positives and negatives. 1 minus 6 is going to get me down to negative 5. So my endpoint D is at 1, negative 5. If you want to see on the graph where that is, that's going to be exactly right there. Okay, so that was your first one. And then from here they ask, what is the distance between 2 points? Anytime we ask you for the distance between 2 points, we're asking for the length of the segment, which is asking for the distance formula. So if you don't remember the distance formula, copy this down with me right now. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and these x and these y values are the x and the y values from the ordered pairs. I usually pick the first one to be my sub 1, so here's my x1, here's my y1, here's my x2, here's my y2. And all we're going to do is we're going to take those values and we're going to go plug them into that distance formula. So it's just plugging and doing stuff like that. The one thing I want you to make sure you're being careful with are the fact that you have parentheses around those x2 minus x1 and y2 minus y1 and that you're squaring them. So if you're going to use your calculator to help you with this, make sure that you're using those parentheses. So you can pause the video here and try those on your own. Alright, you can check your answers with mine. I plugged in my values. I got 4 minus a negative 7, which you can see I put a green plus in between. Subtracting a negative is the same as adding. Plus negative 3 minus 5. I was really careful with my parentheses until the end. I got 11 squared, which is 121, and negative 8 squared. Now notice I kept that negative 8 in parentheses, because anytime you square a negative number, you get a positive. And that's where I see the most type of mistakes occur on this. You need to be careful about that. Alright, you're going to actually do the exact same thing down here. It says find the distance between the points on the graph. The trick here is that you need to find their ordered pairs to begin with. So, I'll give you some hints. Negative x and positive y. And these are both going to be positive. So pause the video, get your ordered pairs, and then check them with mine. Alright, you can see my ordered pairs. So now you're just going to follow the distance formula, which you should have copied down earlier. Plug in your values to the distance formula and try it again. Alright, you can check your work and your answer with mine. I ended up with a 9.5 for the distance between the 2 points. So after we talked about the distance formula and the midpoint formulas, we then moved on to talking about finding the perimeter or circumference of basic shapes. So here we have a triangle in this picture. We're going to find the perimeter of it. So there are some parts of finding the perimeter of a triangle that are pretty simple. Then we're going to talk about how to find the area after that. But to find the perimeter, you just need to know the side lengths. If you look at these, some of these sides, you can legitimately just count how long they are, like that one, from G to F. You count the boxes, it goes over 1, 2, 3, 4, 5, 6. Easy. Go up, 1, 2, 3, 4, 5, 6, 7, 8. Easy. But then you have this slanted side, GE, and to actually find that side, this is where your favorite, the distance formula, comes into play. So we're going to use the distance formula real fast on this one to figure out that side. If using that distance formula, remember distance equals the square root, x2 minus x1 squared plus y2 minus y1 squared, all of it's underneath the square root. We're going to use these ordered pairs G and E. This is going to be my x1 and my y1 on G, and my x2 and my y2 on E. Pause the video, plug those in to get that third side, and then we'll talk about the perimeter. Now you should end up with 10. I can guarantee, like I said this earlier, but on a multiple choice test, you're going to have 10 as an answer. 10 is not the perimeter of the shape. 10 is the side length. To get the perimeter, you need to add up all three sides. 10 plus 8, 18. Plus 6 is 24. The perimeter then is 24. And perimeter should always have a label. Since they haven't told us inches, feet, meters, whatever, we're just going to use U for units. Now area, that's what they actually asked us to find next. We did talk about the area formula for a triangle. Area for a triangle is 1/2 base times height. And you're going to use that a lot second semester. The trick is the base and the height. The base and the height of a triangle have to make a right angle. So you might notice that, hey, that kind of looks like a right angle. It is. We talked about that earlier this semester. We have our base then is 6 and our height then is 8. So we just go area equals 1/2 the base 6 times the height 8. And we multiply that out. we get half of 64, which is 32. And area, much like perimeter, should always have a unit. They didn't, like I said earlier, didn't give us feet, meters, whatever. So we're going to use U, but area is two-dimensional, so you actually take U and we square it. And that is our final answer for this one. I promise you won't have to use the distance formula more in chapter 1 in this video. Here it says find the area and circumference of the circles below. You just need to know the formulas. Area, if you don't remember that one, is pi times radius squared, and circumference is 2 pi r. Let's leave our answers in two forms. Let's represent each answer in terms of pi and round it to the nearest tenth. So in terms of pi and round it to the nearest tenth, you guys pause the video and try the first one on your own. Alright, you can check my answers for that first one. The trick was actually that they gave you the diameter of the circle instead of the radius. So you should have gotten 196 pi feet squared, which is about 615.4 feet squared. For the area, and then for circumference, 28 pi feet, which is about 87.3 feet. Pause the video and try the next one on your own. Alright, you can check your answers for the second one up there. I got area to be 225 pi inches squared, which is about 706.5 inches squared, and circumference to be 30 pi inches, which is about 94.2 inches. So that was chapter 1. And the objective of this video was to get you guys prepared for the chapter 1 questions on the final.